Hello friends, we are still not employed by a FAANG company, so let's not stop lead coding till we get there. Today we are going to do reorder list lead code problem, and solving this one problem is actually equivalent to solving 3 different lead code problems, and I'll show you how in this video. So if we check out the list of companies that have asked this problem, there are tech giants like Amazon, Microsoft, Adobe, Facebook, Bloomberg, Uber, Google, Yahoo, Apple, eBay, Lyft, and Expedia. And these are some of my dream companies, so that's why I'm making these videos. I hope you also enjoy the video. So this is a lead code medium problem, and basically we are told that we are given the head of a single linked list and we need to reorder this linked list and return in a different manner. So let me quickly show you by an example that how do we want to return it. So suppose we are given a linked list like this, that 1 2 3 4. This is a normal linked list we are given, and now we need to reorder it in a manner that one node we take from this left to right direction and the another node we take from this right to left direction. So in this case the first node is going to be this one, this node number 1, and now once we have taken this node from this left to right direction, the second node we are going to take is from the opposite direction. So second node in this case is going to be this value number 4. So second node would be the value number 4. Again, since we have taken node from the end of the list, so next node we are going to take would be this one, the value number 2. So again we will take a node this value number 2, and now at the end we will continue in the reverse fashion, and the next node we will take would be value number 3. So this would this is the sequence we would need to return in this case after all the nodes that we have taken. Now let's take one more example. So again in this case we will iterate, we will take one node from this left to right and one node from this right to left. So the first node would be node number 1, second node would be node number 5, then again next node would be node number 2, then again next node would be node number 4, and then again next node would be node number 3. So in this case this would be the sequence that we will need to return as the result. Suppose this is the linked list we are given and we need to reorder this linked list. So what is the approach we are going to use? Basically we need to understand that what are the things we need. Well, we need all the nodes that are going from left to right, and we are also need all the nodes that are coming from left to right. But the critical part is that this is a single linked list, which means we don't have any way to move in the reverse order. So what we are going to do is, first of all, we are going to create a reverse linked list, and then we are going to merge it with this original input, and the second linked list we are creating, we are going to create it smartly. So this is the input we are already given, right? So we already have our first linked list that we need to create, which is this one. What we are going to do for the second linked list is, for the second linked list, actually for this original given input, first of all we are going to find what is the middle of the linked list. So in this case the middle of the linked list is going to be this node number 4, and the sequence starting from this node to 4 to 4 5 6, this is going to be the middle of the linked list, right? So in this case the first linked list we have is, and for the second linked list we are going to choose it from this middle node. So the second linked list would be, okay, now we have for both our linked list first and second. What we are going to do is, we need all these nodes in the reverse order. So we are going to for the second linked list we are going to flip it in the reverse order. So now for the second linked list we are going to change it in the reverse order. So the second linked list we will have would be like, okay, and once this part is done, for the third part we are going to merge this first and second linked list. So first of all, let's see that what are the first and second linked list we have. Okay, so this is the first and second linked list we have. We are going to merge two linked lists until the point when we get the second node to reach to this null value. And how we are going to merge the list is that first we are going to take the node from this first node, first linked list, then we will take the node from the second linked list. Again we will take a node from the first linked list, again we will take a node from the second linked list, and we are going to keep iterating it until the second reaches null. So let's see that in the action. So first node would come from the first linked list, so this would become our first node. Second node would come from the second linked list, so this would become our second node. Again we will repeat the same process, and in the end we would add this value number 4, And then we realize that we have already reached to the null value for the second linked list, which means that there are no other nodes to be added in the second linked list, which means we would stop adding even from this first linked list, and we would not add all the remaining entries, and this would be our answer, and we can simply return this one. So this is the solution we are going to use. And notice that in this solution we are actually doing 3 different activities. So let's see that how to do each one of them. First of all, we need to find the middle of the linked list, and I have already solved this problem, so you can check out that particular solution over here. Let me quickly go over the solution that I had already proposed. So suppose I have a linked list like this, and if I wanted to do 2 partitions of it, all I'm going to do is I'm going to create 2 pointers. One pointer is slow pointer and second pointer is fast pointer. For the slow pointer, it is going to do 1 iteration to the next element, and for the fast pointer, it is going to do 2 hops to the next pointer. And whenever this fast pointer reaches to the end of the list, this slow pointer would be at the middle position inside the given linked list. So let me show you how. Initially, the fast pointer and slow pointer both would be at the same position. Then fast pointer would take 2 jumps and slow pointer would take 1 jump. So fast pointer would reach over here and slow pointer would reach over here. Again, both of them are going to take subsequent jumps. So slow pointer would reach over here and fast pointer would reach over here. Now again, slow pointer would take 1 more jump, so slow pointer would reach over here. But if fast pointer takes 2 jumps, we already reached to the end of this list, which means that whatever the position of the slow pointer is, this is the part where we need to do a partition, and this would be the middle of the linked list. Next thing we need to do is that we will need to reverse the second linked list. So suppose we are given a linked list like this. So I have already solved this problem as well. You can check out that solution over here. And the idea is that we are going to have two different pointers. One pointer is previous pointer and second pointer is current pointer, and at any point we are going to have the current pointer point to the previous element. So which means, because this is a single linked list, all the nodes are pointing to the next element rather than them pointing towards next element. We are actually going to have any single node point to its previous element, and then this would become our head, and then we would have reversed the linked list. So let me quickly show you how. Initially we would have our current pointer over here and our previous pointer over here. So now, right now, this current dot next is pointing to the next element. So first of all, we are going to create a temp variable, and in this temp variable we are going to store the value of this current dot next. So current dot next we stored. Okay, so temp variable is currently over here. Now we are going to have this current variable which is pointing to this next element. Rather than pointing it to next element, we are going to have it point to this previous element. So now this 4, rather than pointing to this 5, it is going to point to this previous element. So this would be null in this case. Okay, and now once this is done, we are going to have this previous pointer jump to the current pointer. So now this previous pointer would come over here. So this is the previous pointer because we have already updated the value of this value number 4, and then the current pointer, we are going to take its value from this temp variable. So current pointer would also end up over here. So this would also become the current pointer. Once we have this done, now in the next node we are going to repeat the same thing. So first of all, this temp variable, we are going to jump it to the next element. So this would become the temp variable. Again, for the current variable, we are going to point it to the previous element. So now this 5 is going to point to this node number 4 rather than pointing to this node number 6. So we are breaking up this connection. And then for the temp for the current variable, we are going to flip it to this temp variable. So again, current is going to be ending up at this position. So this is where current is and this is where temp is, and then we will update the value of the previous node as well. So this is where the previous node is. So once this is done, again we will repeat the same process, and then we will point when the previous element reaches over here to the last node, we are going to return this as the head. So in the answer, we would have reversed the original list. So we would have a linked list like this, and then once this is done, all we need to do is, now we have 2 separate lists, we will need to merge them. Okay, so for the merge of 2 linked lists, you can check out that solution over here, and let me quickly show you over here as well. We will start taking one node from each of the given list, and first node would be node number 1, second node would be node number 6, then third node would be node number 2, and next node would be node number 5, and then we will take node number 3, and then we will take node number 4 from this list. And now we realize that the second dot next is actually null, which means that now we don't need to take any more nodes from any other linked list, and we can, whatever the answer is, we can simply return this as our answer, and this would be the final solution that we are going to use. So let's see that what would be the time and space complexity in this case. So for the time complexity, we are actually doing three different things. So first thing we are doing is that we are actually splitting the linked list in two parts, so that takes big O of n by 2 time. Plus, second thing we are doing is we are reversing the linked list, which takes big O of n time, and third thing we are doing is we are merging two linked lists, which take big O of n time. So in general, we can say that we are doing big O of n work, and in terms of space complexity, we are actually using an additional linked list, this second linked list, to store the values, and over here we are actually storing like half of the nodes, which means that we will require big O of n by 2 additional space. So generically we can write this as big O of n as well, and this would be the time and space complexity. Let's see that what would be the implementation. First of all, we are going to check that whether the given head is equal to null. If that is the case, we can simply return immediately. And if that is not the case, we will start with our implementation. So first of all, we are actually going to find the middle of the linked list. So let me create two list nodes for that. Now once we have our slow and fast list nodes, we are going to run a while loop, that while either fast is equal to null or fast.next equal to null, we will move slow and fast pointer up until that point. Once this is done, we will have a new linked list starting from the slow endpoint, and we will have to reverse that linked list. So in order to reverse the linked list, we will need a previous node. So we will create a new list node called previous, and we will assign it to the value null. We will also have a current node, and we can initialize it to the value of slow, and we will have a temporary node. Now we will run this loop while the current is not equal to null. So first of all, we will store the value of current dot next into temporary variable, and after that we will exchange the values of previous and current node. So current dot next will get the value of previous node, and previous node will come at the current node, and current node we will need to move one step forward, so we will assign it to the temp node where we initially store the value of the previous current dot next. And after this second loop runs, we should have our second list, the slow list that we created, to be reversed. And now all we need to do is merge our first list and our second list. So let's create a couple of list nodes, and we will create a list node called first, and we will assign it to the value of the head. And we will also create a list node called second, and we will assign it to the value of the previous node. We will run a loop that while second dot next is not equal to null. So over here we will need to take the values from the second node and put it behind the first node. So we are going to use the temporary variable for that. So first of all, in the temporary variable, we are going to store the value of first dot next, and after that, for the first dot next value, we will take a value from the second node, and for the first node we will get the value of whatever the temp value we had already stored. And after that is done, we will repeat the same process for the second node as well. So first of all, we will create the temp to set up as second dot next, and then we will have second dot next to point to the first node, and in the end we will have second node point to the temp node. And once that is done, our code should be working as expected. where we would have updated the value of this original given list node. In this case, we don't have to return anything because the return type is void. We only need to update whatever the given input is. So let's try to run the code. Okay, seems like our code is working as expected. Let's submit the code. And our code is actually pretty efficient and it runs faster than most of the other Java submissions, so which is pretty good thing to do. I would be posting this in the comments so you can check it out from there. Also on the GitHub, I have created a repository of all the questions that we have solved so far, and I have made it public so anyone can access it. I will be posting this link in the comments as well, so you can check it out, this link, and it can be helpful to a lot of other people. So far we have around 60 to 70 questions, and we are growing it by the day.